Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. As promised, in this video I would like to show you how we make the bottle container of this mini blender as shown in this photo. So this is the container of the mini blender. I have already made the dimensioning, the sketch for the dimension of this container. If you look, the left picture is the whole mini blender, and the right picture, the right sketches is the dimension for the container. Okay, the height of the container is 110, and the upper diameter is 125, and the bottom diameter is about 90. And so in order for us to do this container for this mini blender, the best way is to use boss revolve. We have to create a half profile of it, and we do a revolve at the center line. Alright, so in Solidworks, so make sure the unit is MMJS, then we will do on front plane. So in this front plane, I will create a center line from the origin, and the dimension of the container is 110. Then I create a line at the top, horizontal, and I give a dimension. Since the diameter is 125, so the radius will be 62.5, and also since the bottom is 90, so I will create another line here, that line here, and the dimension is 45. Then I will do a spline here. For me to create this curve, I will do a straight segment here. First I will create a vertical line from here to here, and the dimension is about 8. And then for me to do this curve here, I will do spline. So here we have spline, then I will do the spline, just only 2-point spline, and click OK. So at the first angle, I select the arrow and the control point here. Let's make sure that is flow to vertical. So let me do some adjustment of the spline and do some adjustment to make sure we have kind like the contours like as shown here. Okay, I think it's about, okay, the curve is about right. So then what I will do, I will close this shape and connect to this line. So I will do revolve boss base, and the axis of revolution is this line, and make sure it's full circle. So we have the base shape for our bottle mini blender container. Okay, the next move, if you look in this photo of this container, we have kind like a cutout here, like a groove here, and the repeated pattern is about 4. In order for me to do this cutout of this bottle container, the best approach I found out is to use the most basic, is to make a revolve cutout. I've tried using red command and also projection method, and I think it's quite tedious to do the cutout of using that approach. So the best method is to use to make this groove here, is to use a revolve cut with a certain angle, about 40 degrees angle. So let me show you in Solidworks. So if I will do on the front plane, I will create a sketch here, and first thing I create a center line here from this base up until that middle point. So my approach of to do this cutout is to use revolve cut. So it means I have to create a certain profile. I have to create a proper shape here to be cut out, revolve at angle 40 degree. So in order for me to do this, the cutout, so I will select these edges, then I will convert that edges to entirety. So we have a trace of that edge. So let me go to normal view again. So what I will do, I will duplicate this edge. To do duplicate is I will use copy command. Okay, take note on this. I have this edge. To copy this edge to the left, we have option here under sketch, under move entities. We go for copy entities. Entities to copy will be these edges that I just traced, and the distance, if you look on the axis, we are on this to the right is positive x-axis, but we have to copy to the left, so it will be on the negative x-axis. So the distance I need to copy is about -3. So here delta x I will put -3. So it will create a copy of it, and I just click OK. Click OK, then we have a copy version of the trace of the edges. So another thing, the cutout, I already measured the cutout, so I make a line from here to here, a straight line up until it touch that edges. So the distance from this line to this endpoint is 3, and also the distance from this dimension is also 3. So I have and also I need to close it. Then I create the line from here to here to close the loop, and also give a dimension is also 3. So in order for me to do this cutout, it's not quite necessary for me to make a fully defined, as long I have the closed shape and I give some distance here. And okay, then this portion will be trimmed. Let me trim this portion. So I have a kind of like enclosed shape for me to do revolve cut. Okay, then I click OK. So this will be the portion for me to do the revolve cut. So we go to features, we go to revolve cut. Okay, it's already under axis of revolution. If I clear here, axis revolution will be the center line, and you already detect the profile to be revolved, but we are not using full circle. I only need to revolve cut a certain portion. So I'm not using blind, I'm using mid plane. So maybe when at the center I'm using mid planes, it means that it will revolve cut at both direction, and the angle is about 40 degree. So this portion that need to be revolve cut. So then I click OK. So we have a cutout of the base shape of this container. Okay, then I will, after we have made the cutout, I will do a fillet. Since in this photo they have kind of like a fillet at the bottom here, and the fillet radius here is about 5 mm. So I will do a fillet. So on the features we go for fillet, the radius is 5 mm. Then we select all the edges, including these edges. Let me clear this thing first. I go this fillet. First I go for this fillet, then I call a fillet again to fillet these edges for 5 mm. It means we have to do fillet 2 times. Okay, at the bottom we have fillet of 5 mm. Okay, then I will fillet these edges of radius 15. I select this edge and also this edge of radius 15. Okay, we have okay, the next thing is at these edges, since this is all sharp corner sharp edges, so I need to do fillet at these edges. So for these edges I will do fillet of radius 3, and I select these edges, so we have kind like a more curved surface. Then I click OK, and I do fillet again of radius 1 for these edges. So we have kind like a more curved surface rather than sharp edges. Okay, the next move is for me to do repeated pattern of this groove. If you look in this photo, this cutout here have a repeated pattern of 4. So so in Solidworks I will do a repeated pattern of this. So under linear pattern we have circular pattern, then the direction I will use the cylindrical surface, and the angle is 360 degree, and the number is 4. The features, be careful about the features. So the features, I will select the cut revolve, and also not fillet 1 and fillet 2, since fillet 1 and fillet 2 is the bottom fillet that I've created earlier. The need fillet that I need to repeated pattern is fillet 3, and also fillet 4, and also fillet 5. Then I click OK. So I have the the repeated pattern of this groove. Alright, if you look in this photo of the sketches, the bottle container, the thickness is 2 mm. So I will do shell to give a thickness of 2 mm. So under features I go to shell and I give the thickness of 2 and select the top surface and click OK. Okay, sometimes in Solidworks it reminds of the minimum radius of curvature, but for this purpose of training, we just simply click OK, as long as it could form the thickness of 2 mm. So it means we have a bottle container. Alright, another thing to do is that if you look the appearance of this original bottle of this container of this mini blender, the appearance of this groove is kind of like a straight cut, a straight vertical. So I make a certain modification. I want to make it twisted with a certain angle to look, because since this is mini blender, so when we pull the handle, it will do kind of like a spinning of the rod at the middle and the cutting blade. So I need to make the appearance look more pleasant. So the groove here I want to make it twisted at certain angle rather than the original one here is just a straight cutting here, vertical cutting. So I just make some modification to improve the aesthetic look of this bottle container. So the groove here, I want the appearance of it to be twisted at certain angle. Okay, to do that in Solidworks, we can do that under insert here, features, we have flex. The command is flex. Flex, they have kind of, you can change the shape of your solid object. We have some menu here, but the thing I want to do is twisting. So make sure I click at twisting, because I want to do a twisting effect at an angle. So the under flex input here will be the body of this container. Okay, the appearance of, if you look here, this is kind of a gizmo setting of the how we will control the twisting, but it looks that the twisting effect of this right plane and green plane, the red plane and green plane kind of like go for Z direction. So this is not a direction of orientation or twisting that I want. So if my twisting is kind of at the top, at the bottom plane of this green and red color. So in order to do that, make sure on the bottom here, under X here, I go for 90 degree, and the remaining Y and Z I put it 0 degree. So the setting of my twisting of this both green and red plane is right. So okay, under here the angle here I want to make 45 degrees, so it kind of like go to the direction of 45 degrees. So then I click OK. So we have kind of like, we have to wait for a while. SolidWorks got to calculate it. So I have kind of like a twisting effect. So to me, this look more pleasant compared to the original one. It's simply but straight cutting. So this to me is look more aesthetic rather than the original one. All right, let me save my save it as container. All right, our next move, if we look again in this sketching, if I zoom in a little bit, we have a cutout here at the top edge here. We have a cutout of 5 deep and 0.5 the thickness of the cutout. So what I will do, so we have this top plane. I create a sketch at that top plane. So the distance of the cutout is 0.5. So what I will do, let me select this. Make sure we select the proper internal edge. Select this edge, and I convert that to entities. Then I will do an offset of 0.5. Then I select this edge and make sure if you go for reverse, you go for inward direction. Make sure uncheck the reverse, you go to this direction. So we have an extra 0.5 here. So I have these two circles to be used as my profile to be used to extruded cut by the distance of 5. If you look here, the sketch, the distance, the depth is 5. So the distance of the cutout, extruded cut is 5. So we have we have a cutout. So this cutout is meant for us to mount the middle plate that I already did in the previous video. Will be mounted until it stops at this plate. Alright, our next move is that I need to insert the middle plate component that I've done before into this container modeling. The reason that I insert this middle plate to this bottom container, then I put it into correct position for me to know the position of the key. Since if we look the middle plate that I've done before, this middle plate, we have a slot here. We have a slot, and at this container, it means after I put this middle plate at the correct position, so I will know the location for me to do the key. So the key will be slide into that slot, then it will lock the middle container to this the middle plate to this container. So in this container modeling, I will insert part. So I will insert middle plate. So make sure somewhere at the top here, then click OK. Just click yes. Right. One thing that I found out since in this container modeling, previously I've done a twisting effect. When I want to do a matte setting, concentric relation with this cylindrical surface, unfortunately SolidWorks will have lost the properties of this cylindrical surface because I've done a flex modeling, which is twisting. So SolidWorks have lost the concentric surface of this cylindrical surface. So it means that I have to create an extra circle here. At this plane, I create sketch at this plane. Just create a circle and make sure it's snap at the center at any radius. So this circle will be used as a reference for our matte setting relation for concentric. So it means that we need to position the middle plate to be concentric with the this container. So I will move. Okay, then I will move insert features. I will move this middle plate. Okay, under the matte setting. That's why I create the circle here of this bottle container. I create a circle to be. I have the relation of this edge of this circle to mesh at any circular edges of that middle plate, so it have a concentric effect. Then I click add, so it means that the middle plate is positioned to concentric. So the next move is that I need to select this bottom surface of this middle plate to be coincident with this bottom surface. Then I click add, then I click OK. So now our middle plate is in correct position. So from here, then I will know what is the distance of my key for the slot of the middle plate. So in here display style here, I can go for it wireframe mode. Okay, if you look carefully, this is the slot of the middle plate, and this is the top surface of our container. So it means I have to create a key at this position. I have to create a key, but I also found out that the radius of my slot of this middle container is 2 millimeter. The thickness, so I think it's too small. I need to increase it a little bit to make like 3 millimeter. So it means that at I open the original middle plate modeling. This is my middle plate. So I've done this. This one, if you look, the distance, the radius is 1. It means the distance of the slot is 2. So I need to increase it a little bit. So from where I do wrap command here, so this is my wrap sketch, the wrap sketch. So I increase this one to, instead of 2, I increase it to 3 to increase the thickness. So it means I have bigger slot. And also the radius is not correct, so I mean the fillet radius also need to be changed. I edit the fillet. So since the thickness is 3, the fillet radius is 1.5. So it will be 1.5. So we have a bigger thick slot distance. Alright, so then I save my middle plate. So then I back to the container part modeling. So when I update it, so my slot is a little bit larger than 2, is 3 millimeters. So I can do this as a reference for me. So I can check the distance from these edges to this point. So let me check. I can evaluate, measure these edges to this point. We need to know the distance y. Distance y shows that 1.5 millimeters. So I know the position where I will create the key for the slot. So I hope you understand what I try to explain. So under the features, so let me go back the display style to shaded mode. And alright, then I will isolate this container. Let me drag it here. Alright, then I will create a plane 1.5. I will create, okay, I will do a reference geometry plane. Then my first reference is this top surface, and I do for 1.5 is the distance, and I go to flip offset, so it means it go to downward. So we have this plane number 7, little bit 1.5 from the top surface. So this plane 7, I will create a sketch. Okay, I will create a center line from the center point to this quadrant of the circular edge. Okay, that's one thing, the disadvantage of, remember, this center line cannot snap to any properties like quadrant of the circular edge. That's why the bad thing of the disadvantage if we use twist effect. Remember, I do twisting here. Since I have do some twisting of this groove here, Solidworks have lost, this container have lost all the properties like circular edges, cylindrical surface, and so on. So in order to overcome this problem, let me exit this sketch, and I did remember the circle that I did here. This circle I can edit it. I give a proper dimension. Since the top diameter of the container is 125, so I put a dimension of 125. So I exit the circle. So we can use this circle as a reference for our plane 7 to create the center line. So I go to plane 7 again. The plane 7 is 1.5 below. Okay, I create a sketch of this plane 7. Then I create a center line from the center point. Then it will snap to the, now you can snap to the quadrant of that circle. I just adjust the dimension. Okay, the reason for me, then I exit the sketch. The reason for me to do this center line is for me to create a normal plane, since I want to create a key for this at this internal part of this container. The key will be slide into the slot of this middle plate. Alright, so in this container, so I have already created the center line, so I will create a reference plane. So select the line and also the endpoint of the line. So I have a plane plane 13. Okay, sometimes when you do things, your plane does not appear on the screen. Sometimes make sure that under height show your plane is not checked, it's unchecked. Whenever you create a plane, it will be hidden. So make sure that under view, the height show your plane is checked, so it will show the plane. Okay, this plane 12, actually I want to use not this plane 12. This plane 12, I will use it as a reference. This is my first reference at a distance of 3, but I go to flip offset, so I have another plane to the other side. So that plane 13 will be the location for me to create the key. So this one, the plane 12, I off it. So this plane 30, I create a sketch on it. So I have a normal view. Then I will create a center rectangle here, anywhere on the screen. Center rectangle. Alright, then I will position the center rectangle. I select the middle point of the rectangle and hold down my control key and select the center line and make pierce. So it will position the rectangle to the origin point. Then I give a dimension of the length of this key is 6, and also the height is 2. So this will be the profile for me to create the key of this container. Let me drag the view. Alright, then I will do features. Okay, this is very important. Then I will do extruded boss base. Okay, the option that I use for extruded boss base is not from the sketch plane. So when you use sketch plane, it means your starting point is a flat surface. But for my key, I need to be, instead of using sketch plane, I have an option here from surface plane. From surface plane, then I select this internal surface. So it will give me, it will start at that surface. So then I can give the distance, the length of my boss extrude. So the length, since the direction is that is outward, so I need to click a reverse direction. So we will go to inward direction. The length will be 1.5. So it will create a key. But one thing that is also very important, I will not check the merge result. I will uncheck merge result, because why? This will make a separate bodies of the key. Because why I do not I uncheck it, I do not click a check. If I click a merge result, since there will be kind of like I've already done this just to remind you, for this kind of to create this keys, I will click and I uncheck the merge result, so it will create the key as a separate bodies. So then I click OK. So then I have a key at this position. But if you look under the listing of this, we have 3 bodies here. One is cut extrude, is the container, the mid plate that we just hide, and boss extrude is the key. Alright, then what I will do, the next move is I will do a fillet to this key. I will do fillet since the thickness is 2, so my fillet is 0.5. So I will fillet this the thickness of this key is 3, so the fillet is 0.75. so I select all these 4 edges. My mistake, my mistake is 1, supposed to be 1. Since the thickness is 2, the fillet will be 1. Alright, so this will be the fillet for the key. So this key is a separate body. So what I will do circular pattern. Circular pattern of this key. Remember, if I try to do circular pattern, when I try to go the direction, any cylindrical surface of the container is already deleted. Why is it deleted? Because I have used a twisting effect here. The one bad thing about twisting effect, when you do a twisting, the properties of this container, they lost the property of cylindrical surface or circular edges. So my reference will be not this bottle container. So I exit the isolate. So I have this middle plate. I will use the cylindrical surface of this middle plate to be reference for my circular pattern. Let me go for section view so I can see the key. Alright, so this is a section view. Okay, now I can do circular pattern. Okay, under circular pattern, linear circular pattern. Sorry, under features here we have circular pattern. Okay, direction I can go for cylindrical surface of this middle plate, and the angle is 360 degree. The number is 3. But I'm not using features because since I need to circular pattern the key, and the key is a separate body, so I will create, instead of features, I check the bodies. Bodies, I mean we circular pattern this body. So I create the key, then I click OK. So we will have another 2 more of the key. So let me uncheck the section view and let me hide this middle plate. As you can see, we have 3 keys. We already circular pattern. We have 3 keys already in after we have done circular pattern. So these 3 keys is a separate body. If you look the listen, we have 1 key here, second key there, and the third key is there. It is separate body. So we need to join it to the container. So to join it, I will do insert features, and I use combine, then I use add, then I select the container, then I select these 3 keys to be joined as one. Then make sure the option is add, then I click OK. Alhamdulillah, I've completed this container with 3 keys. We have 3 keys, and the next thing to do, let me check this container. Alright, I think I make a silly mistake here. If you look the cutout here, previously I've shown you how I make the cutout of this groove, and the pattern is 4. I forgot to include this fillet to be included into the features of the scalar pattern. So we don't have this cutout, the fillet here. So I need to edit my circular pattern again. Alright, in these features, I need to include the fillet too. And then I click OK. So if this thing happen, rebuild error, so I have to check the geometry pattern. Click OK, then I click OK. Then we wait Solidworks to do the recalculation. And now it looks okay to me, and let me check. Alright, okay. And okay, the next thing is, if you look in this photo, the sketch, I already do a modification. The bottom, we have a protruded cutout cylinder, and the height is 3, and the diameter is 75. And these are the cross-section shape of the cutout, and I can do this by revolve base to the center line. So I have to do the cross-section at the bottom of this container. So what I do in this container, so let me go to the isometric view, then under front plane, okay, here I will do a center line here, make a center line, then I will do a cross-section shape, make sure that it's snapped at the bottom edges. I simply zoom it a little bit. I draw the cross-section shape like as shown in this photo, the cross section shape need to be revolved, and 6 is the length is 6, the height is 3, and all the thickness is 1. So I give a dimension, this is 6 and this is 1. And the height is 3. I need to set this relation into collinear, and I need to give the dimension from here. If you look in this photo, since the diameter is 75, so the diameter is 37.5. So I give the dimension from this point to this point is 37.5. So I have the right position for me to do revolve boss space. So make sure it's full circle, and I click OK. So I have this time-lapse feature. So this groove here, we will later I will do a modeling of a circular ring, rubber ring. The idea of rubber to be fitted into this slot, this groove, to add some extra friction to the surface, bottom surface of this container, of this mini blender. Right, the last thing to do, we have a plane surface here, and we have a small shaft here at the center of this bottom surface. So I will do a sketch on that plane, and I will do a circle of diameter. I will do a circle of diameter 4. Then I will do the boss extrude of, let me check my bottle container. I think the height is about 10 units. So this small shaft here at the bottom surface of the container. So this shaft will act as a guide for, there will be a rod here. There will be a rod here that will be, the rod have blades, some blades, and the rod have internal holes that will be mounted here as a, this shaft support as a guide, or for the rod to be rotated on. So I think the last thing I need to add some chamfer here. Let's go for chamfer 1 millimeter. Alhamdulillah, I have completed the part modeling of this container of the mini blender. Inshallah, in the next video I will do the other parts, like the internal gears, the rod with the attaching blades, and some other components of this mini blender. Okay, please like and subscribe on my video. So inshallah I will see you soon in the next video. Assalamualaikum warahmatullahi wabarakatuh.